final lesson in chapter 8, we're going to look at perfect squares first. We're going to factor perfect square trinomials, and we're also going to solve equations with perfect squares. We also are kind of going to do some things that are review from other units that you've seen. So, first of all, the idea of a perfect square trinomial. Back, I think it was in lesson 8.4, where we kind of learned some shortcuts about how to use the FOIL instead of having to FOIL this out and then simplify the middle terms. When we had a perfect square like this, a binomial that is being squared, we learned a shortcut. Actually, let's go ahead and we'll FOIL this one to see how the shortcut works. So if we FOIL this, it would be x plus 3 times x plus 3, right? And then we would do x squared, squared plus 3x plus 3x plus 9. And then when you simplify the middle terms, it comes out to x squared plus 6x plus 9. And so the shortcut we learned for multiplying perfect squares is that we take the first term and square it, which we have here. We take the last term and square it, which we have here. And then we take the first term times the second term, so x times 3 is 3x, and we multiply that by 2. So 2 times 3 is 6, 6 times x, right? And that's what we have here in the middle. So if we follow that pattern here, this is going to be a little bit different since we have a minus, but it's going to be 2w squared would be 4w squared, okay? And then we need a minus sign for the b term. We're still going to have a plus sign for the c term. What is 5 squared? We'd have a 25 at the end because we got 5 squared at the end. And then the middle term, we'd have these two times each other. So 2w times 5 is 10w, but then times 2, right? So minus 20w. And that's the kind of the shortcut when we know we have a perfect square. So these products are called perfect square trinomials. Yesterday we had differences of squares where we only had 2 terms. Now we have perfect square trinomials because they've got 3 terms, first of all. But notice that the first term is a perfect square. The c term, the last term, is a perfect square. And the middle term is 2 times the product of the binomial terms. So we're going to use that information to turn that around and factor perfect square trinomials. So first thing that you want to do when you see a trinomial is look at it to see if it might be a perfect square trinomial. Is the first term a perfect square? 16x squared. Is that a perfect square? Yes. C is the last term a perfect square. Is 9 a perfect square? Yes. And now, is the middle term 2 times the product of the square roots of the first and last terms? What is the square root of the first term? 4x. And what is the square root of the last term? 3. So 3. What is 4x times 3? 12x. And what's 2 times that? 24x. So if you can take the square root of the first term, multiply by the square root of the last term, and then multiply by 2 and get the middle term, you've got a perfect square trinomial.
That sounds like a lot.
It sounds like a lot of work, but really once you see it, it's not bad. It's really not bad. I mean, you can do that in your head. We didn't even have to use a calculator. Okay, so we would factor this then simply by taking 4x plus 3 squared. All right? So, on these next few slides, determine if each trinomial is a perfect square trinomial. Write yes or no. If yes, factor it. So, is the first term a perfect square?
Yes.
Yes. 4y. Is the last term a perfect square?
Yes.
Yes. 3. Is the middle term 2 times the product of the square roots?
Yes.
No.
4 times 3 is 12, but then we have to multiply by 2, which is 24. So this is not a perfect square trinomial.
But the square root of 4 is 2.
Okay, let's back up. What is the square root of 4y? 2y. What is the square root of 9? 3. Is 12y 2 times? Oh! You guys stink. All right. Thank you for pointing out my mistake. All right. Anyway, I'll make excuses, but I was wrong. All right. So 2y plus 3 squared is how we would factor that. Okay. Holy smokes. I was surprised I was starting off with a no, to be honest with you. All right. Is 16y squared a perfect square?
Yes.
What's the square root? I'm going to make you say it this time. 4y. Is 25 a square root, perfect square?
Yeah.
Okay. 5. Ooh. You got,
Yeah. Well, what?
Yeah.
No, because
It's minus
negative.
5. -5.
okay. So 4y.
Yeah, you can.
But yeah, so it's not going to be two positives. We're going to have a minus, right? 4y, if we take 4y times a minus 5, we get negative 20. And then 2 times negative 20 would be minus 40. So this one works as a perfect square. So the perfect square trinomial. So this is a yes. Okay? All right, so is this a perfect square trinomial?
No,
Why not?
because you can't get the square root of 2.
All right, 2a squared is not a perfect square. All right, 2 does not have a square root that is a whole number. Okay, so this one is a big fat no. I like those, they're easy. All right, determine if each trinomial is perfect square. So 25a squared,
5a.
5a, and then 36
6.
is 6. Since this is minus, it would have to be minus 6. Does this work as the factor?
Yeah. Wait, no.
No, it doesn't because we wait 6.
Yes, this should be 60. Good job. All right, that's not the right number for it to be a perfect square trinomial.
Get this, guys.
5a times 6 is 30. Okay, so this will not factor. All right, so this is a no. All right, now this slide, now we're getting back into, wait a minute, that's not, sorry.
My sister was doing that homework class.
This is a slide from the wrong unit. This is a pre-algebra slide.
Yeah.
Forget this one. Sorry, I was supposed to stick a different slide in yours that had some reminders about factoring, and I grabbed the wrong picture. My bad. All right. This is going to be a great one to post as a recording, by the way. All right. So, factor each polynomial if possible. If it cannot be factored, write prime. So, that last slide was supposed to give us some steps. Step 1 is factor out any common factors. So do these two terms have any common factors?
5.
Yes, 5 will go into both of these. So the first thing before we try factoring it is we have to factor out a 5. So this would be 5 times x squared minus
16.
16. Good. All right. Now this goes back to a previous lesson, x squared minus 16. What did we call these? Difference of four-sided figure squares. Thank you. Difference of squares, because this is a perfect square and this is a perfect square and it's got subtraction in it. So we can factor this to be x plus and x minus what?
4.
X plus 4 and x minus, oops, forgot to put a 4. X minus 4. Okay? So that's if we factored it, we would leave the 5 there. All right, so we factored that one. All right. Factor each polynomial if possible. If it cannot be factored, write prime. So, is there anything that we can factor out of all 3 terms?
3. No.
3 does not go into 35.
One.
No.
1 is the greatest common factor, so we can't factor anything out. Is it a perfect square trinomial?
Yes.
No.
No.
9 is a perfect square, but 35 is not, so it's not a perfect square trinomial. So now it's not a perfect square, so now we have to go to the next step, which is just factor this puppy. So to factor these, we use the box method. Some of you loved this, some of you hated it, but we're going to use it still. So 9x squared goes here, and minus 35 goes here. Wow, 9 times 35 would be 270 plus 45, 315. So 35 times 9, 315. I was right, all right. So factors of 315, holy smokes. 1 and 315 doesn't do us any good. 2 doesn't go in, 3 doesn't go in, 4, 5 will go. 5, 6, and 63.
15 and 12. I'm thinking 21. 15 and
Actually, 3 will go into that. 15 and what?
21.
15 and 21, that's the one we want anyway. Okay, so there are a bunch of factors into 315, but we only need this one. Okay, so,
I got it until this point.
okay, well, hang on to what you got and we'll work on the rest later. All right, so I need a plus what and a minus what?
Minus 15 and minus 20.
That's got to be a minus and a plus since this is minus.
My bad.
So plus 21
Yeah.
x and a minus
Uh,
15x.
no other way, because it's a minus.
It's the other way because it's a minus.
Oh, that's, you said that and then I did it backwards, sorry.
I can't.
So minus 21x and plus 15x. All right, so common factors with 9x and 15x. 3x. Common factors with 21 and 35. 7. And since this is a minus, we've got to put a minus here. So minus 7. 9x and 21x. 3x again. And then 15 and 35.
5.
So 5. And since that's a positive, it would be a plus. So our factors are 3x minus 7 and 3x plus 5. And that one's done. Holy smokes. I'll try to make fewer mistakes on the next one. Sorry. Okay, factor each polynomial. So can we factor anything out?
2.
2. So we can take a 2 out. We've got x squared minus 16. Now we've got a difference of squares, right? So it's 2 times what?
X minus
X.
8.
Minus 4.
X plus 4 and x minus 4. Okay, so that one's factored. All right. Can we factor anything out?
No.
No. So we've got to factor this puppy. All right. It's not perfect square trinomial because 12 is not a perfect square. So we'll draw our little box over here. 12x squared, 12x squared and 25 minus 25. So we have 300, right?
Mm-hmm.
300. So 12 and 25 don't do it. So 15, what's 15 times 20 would be 300. Those are the two factors we want, 15 and 20. So we need a minus 15 and a plus 20. Minus 15x and a plus 20x. Factors of 12x squared and 15x.
3x.
3x and 20x and 25.
5.
would be plus 5. 12x squared and 20x,
2. 4.
Five.
4.
4
Yeah.
4x, and then a minus 15 and a minus 25.
Five.
Negative 5.
Minus 5. So 4x minus 5 and 3x plus 5. All right, solving equations with repeated factors. So now we've shifted from just factoring into solving equations. So what is the first step in solving an equation?
Make 0.
Make it worth 0. So add, 64. Add 64. We've got 9x squared minus 48x plus 64 equals 0. All right, can I factor anything out?
Yeah. I think.
3 does not go into 64.
I mean,
No.
8
No,
times 8
yeah.
and then 3.
2. No.
Okay, so can't factor anything out. Now the question is A a perfect square?
Yeah.
Okay, is C a perfect square?
Yeah.
Okay, so we'd have 3x times 3x would be 9x squared, and then we'd have 8 times 8 is 64. What's 3 times 8? 24 times 2 is
48.
48. So we've got a perfect square trinomial. So what symbol goes in the middle here? It's got to be a minus. So we've got 3x minus 8 squared equals 0. So that's 3x times minus 8 times 3x minus 8, right? Well, cool. So they're both the same factor. So all I have to do is factor it one time, or solve it one time. 3x minus 8 equals 0. Add 8. So 3x equals 8. Divide by 3. So x is 8/3. And that's the only possible solution. I don't have to solve it twice like we typically have had to do. Okay, so when we have repeated factors, you only have to solve the equation one time. That makes life easier, doesn't it? All right, at least less work. I don't know if it's easier. All right, this one's already worth 0, so I've got, do I have a perfect square here?
Yep.
Perfect square here?
Yep.
Yeah.
Okay, so this would be a and a 6. 1 times 6 is 6. 6 times 2 is 12. So I've got a
Plus.
plus sign there. A plus x, a plus 6 squared equals 0. Solve it. A plus 6 equals 0. So a equals negative 6.
Really?
That one's really easy. I like it when there's a 1 coefficient in front of the first as the leading coefficient. All right, so here's a new property. It's called the square root property. And we can use the square root property to solve these equations because is y minus 6 squared a perfect square?
No.
Yeah, I can take a square root of that because the entire thing is squared. So I can take a square root of this, right? Is 81 a perfect square?
Yeah.
Yes, so I can take a square root of that. So what is the square root of y minus 6 squared?
1 minus 6.
Y minus 6. What is the square root of 81?
9.
You're half right.
3.
No.
18. You said I'm half right.
Yep. So 9 is correct.
Wait, when you get to
But there's something else.
9 squared.
Not 9 squared.
Yeah.
So think about what this means. Wait a minute. What does the square root mean? It means that there are there's a number that you can take times itself to get 81, right?
Yeah.
So I can do 9 times 9 equals 81. That's true. There's something else I can do times itself to get 81 as well. Negative 9 times negative 9 also equals 81.
Why does that matter?
Okay? Because it could be either one of these. I don't know if it's positive 9 or if it's negative 9. And so here's how you write your solution. Y minus 9 is plus or minus 9.
Oh, this is the little crossy thing.
This little crossy looking thing. Usually these run together in the book.
Oh,
The symbol looks like this in the book. They usually kind of even touch each other. I don't know why they make it do that. It makes it more confusing to me. But, oh, no, not that button. Sorry, that button. Okay. Now I want to solve this. So I've got two equations here that I have to solve. I've got to do a y minus 6 equals positive 9 and add 6. So y equals 15. I've also got to do y minus 6 equals negative 9. Add 6. So y is negative 3. Okay, so my solution is y equals negative 3 or 15. Okay? All right, so that, same deal here. Use the square root property to solve each equation. Sometimes we don't get a clean solution to these, and it's okay. We can still take a square root of this, right? I can take a square root here, and x plus 2 equals, to me, the simplest way to solve these is not, you could put the square root of 12 into your calculator, it's going to spit out some, it's like 3.69712.9. You know, it goes on and on and on. It's an irrational number. It will never stop. It will never repeat. I don't like those numbers. Those are confusing. You know what I like? I like this right here, plus or minus the square root of 12. Okay? So how do I solve this? I've got to do x plus 2 equals positive square root of 12. Subtract 2. So x equals square root of 12, and make sure that your minus 2 is outside of the square root box. And then you've got to do x plus 2 equals the negative square root of 12. Subtract 2. So x equals negative square root of 12 minus 2. So x equals negative square root of 12 minus 2, comma, square root of 12 minus 2. That's how your answer would look. I like that better because anything you do with a decimal is just an approximation. It's not going to be as accurate. This preserves the problem, what it looks like. You could reconstruct the problem using this information. All right, everybody good on that one?
Yeah.
Let's try this last one. It's going to be very similar to the one we just did. Just wanted one more practice on this one. So z plus 3 squared, take the square root of both of those. Z plus 3 equals what?
Square root of 26.
Say it accurately.
Plus or minus.
Plus
Plus
or
or
minus
yeah.
the square root of 26.
I didn't write that.
Okay? So z plus 3 equals the positive square root of 26, which means z equals the square root of 26 minus 3, and z plus 3 equals the negative square root of 26. So z equals negative square root of 26 minus 3. Okay, so your final solution, z equals negative square root of 26 minus 3 and positive square root of 26 minus 3. Okay? All right. Assignment is the 8-9 skills practice worksheet.
Oh,